Hello everyone, good afternoon. Myself Anjana Reddy, chemistry faculty. Today I am going to discuss with you a simple topic called hydrocarbons, comes under chemistry. So I am going to discuss with you regarding the hydrocarbons introduction, classification, examples. Let us start hydrocarbons. The word hydrocarbons made up of two simple words, hydro and carbon. Hydro means hydrogen, carbo means carbon. Together it is hydrocarbons. So simple definition is like this. These are the simple organic compounds which are made up of mainly two elements such as hydrogen and carbon. Now coming to uses, why we need to discuss hydrocarbons? Because nowadays hydrocarbons play important role in all the fields, especially in fuel, acts as a fuel. Hydrocarbons acts as a fuels. For example, fuels like LPG, CNG, LNG, all these are made up of hydrocarbons and their mixtures. For example, LPG. What is the expansion of LPG? Liquefied petroleum gas. Liquefied petroleum gas. The main composition of LPG is mixture of propane and butane, used as a fuel, domestic fuel. Coming to CNG, expansion, compressed natural gas. It is mainly made up of hydrocarbons such as methane. Coming to LNG, expansion, liquefied natural gas. The main composition we cannot decide because based on the processing conditions, LNG composition decides. However, all these are used as fuels. And so hydrocarbons also used in biofuels, biogas. Biogas is also mainly made up of methane. So this is about uses of hydrocarbons. Coming to classification. So classification wise, if you see here, there are four main types. Hydrocarbons are mainly classified into aliphatic hydrocarbons, aromatic hydrocarbons, alicyclic and heterocyclic. Let us take first one, aliphatic hydrocarbons. So aliphatic hydrocarbons means these are the hydrocarbons containing open chain structures. There are carbon atoms bonding with both the single and double bonds but having open chain structures. Based on the nature of linkage or bond, we can divide aliphatic hydrocarbons into two types such as saturated hydrocarbons and unsaturated hydrocarbons. Now let us take saturated hydrocarbons. These are the hydrocarbons containing open chain structure with the carbon-carbon single bonds. Carbon-carbon single bonds. Hence, saturated hydrocarbons are also called alkanes. Important name. So, alkanes having the general formula CnH2n plus 2. Where N start from 1, 2 and so on. A few examples like this. If I give N value 1 in the above formula, we get CH4. It's a name methane. This is the first member of alkene series. A second one is, if N is equals to 2, it's a value C2H6 ethane and so on. This is about Saturated hydrocarbons. I can write here general formula important CnH2n plus 2. Now coming to unsaturated hydrocarbons, in the name you see unsaturated, that is not satisfied. What is not satisfied? Valence is not satisfied. To balance that, there must be either carbon-carbon double bond or carbon-carbon triple bond in the structure. So coming to definition, what are unsaturated hydrocarbons? These are the aliphatic hydrocarbons. In the open chain structure, they contains either carbon-carbon double bonds or carbon-carbon triple bonds, and together we call it as multiple bonds. So based on the nature of linkage, we have two types of unsaturated hydrocarbons: alkynes and alkynes. Now let us take the first one. Under unsaturated hydrocarbons, alkenes. What are alkenes? These are the unsaturated hydrocarbons having open chain structure containing at least one carbon-carbon double bond. They have the general formula CnH2n with the n value 2, 3 and so on. If you see here, the starting value is 2 onwards, because to having a double bond there must be 2 carbon atoms. If I give n value 2, you get the formula C2, so it is H4. So it's a name ethene. And one more example, n is equals to 3. It is n is equals to 3, substitute here C3. 3 2s are 6. It is propene. If you see in this alkene series, it ends with ENE, because according to IUPAC, carbon-carbon double bond name is ENE. That is about alkenes. Coming to another kind of unsaturated, it is alkynes. What are alkynes? Alkynes are also unsaturated hydrocarbons, but they contain carbon-carbon triple bond in their open chain structure. Here also, valency of carbon is not balanced. That's why to balance the valency, they contain triple bond in the structure. And alkynes having the general formula CnH2n minus 2. Here n value also start from 2 onwards, 2, 3, 4 and etc. If I give n is 2, you get the first formula C2. 2 2s are 4 minus 2, it is C2H2. It's a name ethine. So propine, butane and etc. If you see, all alkynes ends with the YNE, same in the IUPAC name nomenclature. Triple bond name ends with the YNE. And I'll come to back. Alkanes are also called saturated hydrocarbons. Alkenes and alkanes are called unsaturated hydrocarbons. Alkenes having another name is called ethylenes. Common name called as ethylenes. And alkanes common name called acetylenes. That is about aliphatic. Now let us move on to second main type of hydrocarbons, aromatic hydrocarbons. In the name aromatic hydrocarbons, aromatic hydrocarbons. Aroma means smell or odor. It's a Greek word actually. Smell or odor. My question is, which hydrocarbons possess this characteristic odor? To possess characteristic odor, that compounds must having this kind of ring structure. This ring structure is called as a benzene. So definition like this: these are the hydrocarbons which must contain at least one benzene ring in the compounds. In simple words, benzene and its derivatives we call it as aromatic hydrocarbons. Examples: benzene itself, benzene with the other side groups like OH, we call it as a phenol. Benzene with the side group of CH3, we call it as a toluene. Benzene with the NH2, we call it as aniline. Benzene with the just Cl, it's a chlorobenzene. You see, in all these examples, there is a minimum one ring must be. And there is a question here: are aromatic compounds must not only one benzene ring, more than one benzene ring also. For example, benzene and benzene together. So this is dibenzene. Actually, its name is naphthalene. Naphthalene. 3 benzene rings also. It is called anthracene. So that are called aromatic. Coming to last one, polycyclic and heterocyclic hydrocarbons. Coming to polycyclic. The name only there, no, polycyclic. Polycyclic. If you see this word, we can divide it into two simple words: poly and cyclo, or cyclic. Poly means aliphatic, or also called alkanes. Cyclic means ring compounds. So its definition is like this: these are the cyclic compounds or ring compounds, but having the properties similar to alkanes. So therefore, they are called polycyclic hydrocarbons. Another name is cycloalkanes. Cycloalkanes. The other formula is like this: CnH2n. You see, here also there is a general formula of alkenes, CnH2n. But there is a small difference between cycloalkanes and alkenes. General formula is here n value start from 3 onwards, because to get a cyclic structure we must have 3 carbon atoms in the ring. Examples: we can write some geometrical symbols or diagrams like this. Name is like this: cyclopropane, cyclobutane, cyclopentane, cyclohexane. All these names start from cyclo. If you see here, inside the cyclic structure, there is only single bonds in between the carbons. That's why, though they contain cyclic structures, but their properties are similar to single bond compounds, that is alkanes. Hence, they are called polycyclic compounds. Coming to heterocyclic hydrocarbons, it's a very important. Heterocyclic. You see in the word, so hetero. What is meant by the term hetero? Hetero means different. So these are the cyclic hydrocarbons, ring compounds. But in the ring structures, that corners of the ring atoms are replaced by one or more heteroatoms. Hetero means different. Heteroatoms are like nitrogen, sulfur, phosphorus, oxygen, and so on. If you see examples, so for example, first one, pyridine. Pyridine structure similar to benzene structure, but what is the difference? In benzene, all the corners containing carbon atoms, but here in a pyridine, one of the corner is carbon atom replaced by nitrogen atom. That's why there is a small difference. Here all the corners are containing carbon. Here nitrogen is there. That's why here nitrogen is different. So that are called heterocyclic. One more example. So furan. Furan structure is like this. Here actually carbon must be, but instead of carbon, if you take oxygen as a heteroatom, that is furan. Of course, many other examples are there, but these are the main examples of this category. So this is a brief classification of hydrocarbons. So next, in the next video, I am going to explain preparations, properties, structures of these compounds. Thank you.